Hey guys, I just want to give an update of SNES-Tap. Last time I put a video up, I showed you guys a partial save and load state of Mega Man X2 with some visual artifacts. Since then, all those visual artifacts have been cleared, and I have X, X2, X3 working. So let me go ahead and show a demo of that and a couple things at the end. So let me go ahead and load into X. I already have 5 states already pre-saved, so I can already jump in between those 5 states. So let me go ahead and do that right now. So here's a title screen, and here are some other levels. And you can see I can jump through them pretty quickly. As you notice, one of the things that's not really fully supported is the sound. There really isn't save and load state with the sound, mainly because it is a separate processor on SNES. It's really tough to figure out how to load and save its state. But as you notice here, if you were to restart the level, it will initiate loading the music in, just like that. And the music will be maintained when you switch over to other states. Alright, so let me show X2 real quick. And for that, I have preloaded states for that, so let me go ahead and place those in. And start up X2. We're in the title screen, or the character select screen. And here we are jumping around. Between states. We can load music by going into a stage. And it will be maintained when you go from state to state. Okay, let me show X3. Take those preloaded states and place them into the folder. Switch to card out. Load into... I loaded in between a sound segment. Let me restart and try it again. Sometimes you can get it to soft lock if you load it in between when it's loading music into the APU. So there I just loaded it during a Capcom sequence. And you don't have the music for the character select screen, but you do have the sound effects. So, and here I'm jumping around. And just like the other games, you can reload music. Let me just show you how to save state. So you can do the hotkey to save state like this. And load it through. Save here. Load it. So there is load and save state support for X2 and X3. So one of the other things I wanted to show real quick is how to develop a hook for SNES-Tap. As you can see from the beginning splash screen here, if we go all the way up, here we are. You'll notice that we have hook page 1 through 11 loaded in, and each one of these hooks describes 124 bytes of instruction data. Unfortunately, 124 bytes is the area that the SNES-Tap can address due to its limited range on the address bus B. So what we have to do in order to do something like load and save state, we have to split all the functions into hook pages and jump the program counter back to the beginning of our address space and load a new hook page. And so the FPGA handles these hook pages and handles bringing the program counter back to the beginning to load the next hook page. So in this case, we have each of the routines involved in loading and saving a SNES state, but they're split into 11 different hook pages because they require a lot more than 124 bytes to be described. But one of the things I want to show is how to make one of these hook pages, and I'm going to use Rockman X as an example. So I'm going to reload Rockman X here, and I am going to define a new hook page for our development environment. So there are a couple things involved in the hook page. One is the assembly for the hooks. So here's the load save state Python plugin that registers your hook pages. And we're going to make a similar one for our X test. So I have one right here. It's very simple. This imports right into our SNES console. And here we're loading xtest.bin Mega Man test hook, which we're going to build out of assembly. And so we're just going to go ahead and save this. If we go down to our xtest assembly, there's a couple of semantics here to describe the start and end of the hook for the assembler, but for the most part you can write your hook code here. So one of the things I want to test is just taking something like a Pro Action Replay code and applying it as a hook to be executed during every NMI. So let me go ahead and find, here is a web page of Mega Man X Play Action Replay codes. One of the things I want to try is this jump height modifier. So if you read this code, what this is saying is at bank 7E address 0BC6, this is the byte that controls your jump height in Mega Man X, and it's question mark. You have to read point 7, and here are the selections. So if you specify 6.4, it's a normal jump. If you specify 0.8, it's an ultra jump. So let's go ahead and convert this into a hook. So for that, I am going to write a couple of lines of assembly. So one of the things we need to do is we want to write 0.8 into that address. So we're going to head and load the accumulator register with hexadecimal 0.8. And then we're going to take the accumulator and store it into 7E0BC6, which was the place in memory that controls X's jump height. So we're going to go ahead and save this. And going to go ahead and make our hooks. It's going to make all the load and save state hooks that were used during the previous demo, and it's going to create our X test hook at the end. And so here it is. And it places it into our hooks directory so that our driver can pick it up. And since we saved our plugin should also be loaded. So let's go ahead and load the console program. As you see here, we have all the regular load save state hooks, and we have this extra hook called the Mega Man X test hook, and indication that the plugin loaded. So let's go ahead and try it out, see if it works. Power it on. So let's go all the way to the intro stage. And now X jumps really, really high. So let's go ahead and do a modification of this hook. One of the things that the assembly hooks can do that Pro Action Replay can't is provide the semantics of conditional statements and other things that are provided by the processor through assembly instructions. So yeah, you can mimic a play action replay code, but you can't do anything but freeze a memory address. So let's try something that's a little bit more advanced, where we conditionally decide to jump high when X is in a certain orientation. So for that, I'm going to go ahead and load up the website that has the RAM map for Mega Man X at testvideos.org. If you go ahead and read this through, there's one interesting location that I'm going to test out, and it's X's direction. So if you were to read 7E0C11, if X is facing left, it's a 0, 0. If X is facing right, it's a 4, 0. So let's go ahead and write some code there to leverage that. So we already have our code to make X jump high. So I'm going to go ahead and load into the accumulator that address of the orientation of X. So 7E0C11. So we're going to load that into the accumulator. Next, we're going to compare the accumulator with 0. So we're going to check if the value in the register that has X's orientation is 0. And if it's not, then it's probably 40, and he's facing the other direction. So the next thing we're going to put is our conditional operation. So we're going to branch if we're equal to a label called skip. And a skip label I'm going to define after the jump enhancement code. And that should be it. So let's go ahead and test that out. Going to exit the SNES console real quick. And we're going to make all the hooks again. And our excess hook is recompiled. So let's go ahead and reload the SNES-Tap console. And we're going to restart the game. So press R. And let's try our new hook. So if X is facing this direction, he should still have his height enhancement. But if X is facing this direction, he has normal jump. So that's a kind of a good example of how you can use more advanced conditional statements in assembly to add interesting hook code to Mega Man X. Anyway, that's all I wanted to show in this video. There will be more details on this project going forward, and hope you enjoyed it.